Okay, we are addressing what we might call the problem of the black box. This is in the context of what I'm calling machine learning ethics. So we want to talk about algorithmic accountability, algorithmic bias, and also reinforcement learning, which also mainly takes accountability and bias, but it's very different, so it deserves its own conversation. So here we are in the context of algorithmic accountability. So if you're new to these videos, what we do is a 6-question framework to describe the problem. We start out with a description of the problem. We try to think about what we already know about the problem, what's familiar about the problem, what's new because of the scale of digital technology, also what's new because of the capabilities of digital technology, which ethical value we're talking about, and then any potential solutions. So we start out with what is the problem. So the metaphor black box, I think probably everybody watching the video series understands this, but just start at the beginning. So in the metaphor, box describes a system, some kind of components that work together to achieve some goal or objective. Black, of course, does not refer to a color, but a light spectrum, as in opaque. So metaphorically, you can't see through it. Non-metaphorically, it's a system where you have inputs and outputs, and the inputs and outputs might be more or less understandable or describable or observable, but how the inputs turn into the outputs is not understandable. So a black box is a phrase for a system that we don't understand how it works, specifically how the inputs and outputs are connected. Okay, what is familiar about this problem? So I think it's pretty obvious that people are comfortable using systems that they don't understand. In fact, I would go a little farther and say that's the norm. So many of the systems that we use, we more or less understand the inputs. Like you understand what you input into your computer. You understand like the outputs, the expected output, but how those inputs turn into the output, I think the vast majority of people couldn't really explain. With cars, same way. I think obviously there are people who know all about cars, but I think the vast majority of people that drive have no idea at all, or maybe you have some vague conception of what an engine does, but not a very good conception. Okay, so the assumption, though, and I'm pretty confident about this. So I know that from observation that people are comfortable using black boxes or systems that they don't understand. But I'm pretty sure that the assumption is that I feel comfortable using it as long as there is someone that I trust that does understand that system, right? So I don't think anyone would be comfortable using a system that is not understood by anybody or that is not able to be understood by anybody, right? So if you're getting on a plane and you find out that not only do you not know how this plane works, but no one knows how the plane works, I do not think anyone would want to get on that plane. Okay, what's new here because of the scale of digital technology? Well, machine learning algorithms, turn inputs into outputs into ways that we just can't fathom. Right? In fact, you might even say that's the point of them, right? Because if human brains, would be able to make those connections, we might not need the algorithms to do that for us. So, what factors ramp up the scale? Well, there's a few factors. The ones that are probably most obvious to talk about would be dimensionality and linearity. So systems, the more linear they are, the easier it is to understand, right? So if the output goes up corresponding to the input, I can kind of wrap my head around that. If a system, if a machine learning model has 2 dimensions or 3 dimensions, I'm good with that. Human beings are able to think in 2 and 3 dimensions. But when you start talking 4, I get a little confused, and when there's 500, forget about it. So those are the kind of factors that that make it a black box, that make the system impossible to understand. So there's a lot of words flying around in this space for how to describe this. What I'm going to focus on is the word non-comprehensible. So what I mean is when you can comprehend something, you can, so to speak, process it, trace it out, go over the steps in your mind. So if you can't do that, it's not comprehensible. Okay, so dimensionality, obviously, if it's 2 or 3 dimensions, I can kind of process that. I can kind of trace it through in my mind at a certain 4 or more. That's not going to work out for me. Okay. So what's new because of the capabilities of digital technology? So, the very concept of machine learning is what actually increases exponentially the complexity of the black box. So, if there are examples that I'm not thinking of, that's fine. It doesn't ruin the point. But as far as I know, engineers, when they're designing a system, tell it what to do. Machine learning models don't work that way, right? We set it up, we set the parameters, and we optimize and stuff like that. But we are telling the algorithm how to do it, not what to do. So the algorithm learns autonomously, which means it's learning things in ways that we don't understand. We just told it what to do, and it's doing it. That's the very essence of machine learning, of course. So which ethical value is relevant? Actually, just about all of them. So it's complicated enough that I'm going to have another presentation in this series called The Problem of Explainable Models, and then there's another one called The Problem of Dignity that adds on to that. Because values are all over the place here, and it's actually kind of complicated, so I just need a separate video to map it out. But just suffice it to say that every ethical value you can think of, fairness, trust, virtue, autonomy, happiness, they're all on the line if we're talking about relying on models that are not understandable. So, potential solutions. So the solution that jumps to everyone's mind first is transparency. Okay, so this completes the metaphor, right? So if the problem is that the black box, if the problem is that it's opaque, making it transparent should be the solution. So that sounds nice. That is not going to work, however. So, if we're talking about a model that has 2 or 3 dimensions, if we're talking about a model that's more or less linear, a linear regression with 2 dimensions, yes, transparency, just show me the model and then I can kind of understand for myself, right? But of course, in the age of AI, the kind of systems that we're using aren't anything like that. So, what good is transparency going to do? And I'm not saying that transparency is a bad thing. Transparency is often the right answer or the best answer to problems, right? So why are people doing things? Tell us, what your motives are. And, even in this context, it's like, what are the parameters for the model? It's like, if you be transparent about that, it might help us get some kind of insight into the system. But transparency, at best, is a means. It's a way to get something. And what transparency helps us get is comprehensibility. And that's going to be important here in just a second. I'll explain why the means end language is important. Because we need to think about our true goal, or what should be our true goal. I think our goal in dealing with black boxes is accountability. Okay? So accountability is what allows us to evaluate and then manage the model in the ways that we want. Okay? So if a system, if we can do those 2 things with the system, if we can evaluate it, if we can manage it, then I think that system's accountable. I think that's what we should want. And I think if we really reflect, that's probably just what we do want. Now, that's the goal. How do you get that goal? Okay, so here's where it gets a little tricky. You got to maybe draw out some arrows for yourself or something. But comprehension is the most obvious way to get accountability, right? So if you can wrap your mind around something, then it's accountable. You can understand it, you can evaluate it, and you can manage it, right? But what I want to say is that accountability being the true goal, comprehension is just one way to get that goal, okay? Explanation is another way to get that goal. And as I'm going to explain in other videos in this series, explanation and comprehension are quite different, okay? So we have a goal and we have a way to get the goal, comprehension. Or if you want to start the process, we have transparency. Transparency gets us comprehension. Comprehension gets us accountability. But given the nature of machine learning models, comprehension just isn't possible. And so transparency just isn't useful, right? And so we need another strategy if we want to hold models accountable, which we do, right? As I said earlier, I don't think anyone would engage with a system that is unaccountable, okay? So comprehension as a structure of transparency. It's not an end in itself. It's a way to get what we actually want. Okay, so these are some thoughts about the problem of the black box. And this is the first video in the series on algorithmic accountability.